Time to rock and roll with set theory. Subsets is the next thing we're going to talk about in sets. And we're going to recognize subsets, use the notation, proper subsets we'll talk about. And that notation, notice that it's very similar, except it doesn't have the equal sign. Third, number of subsets. Boy, this is going to be easy. You're going to like this one. And fourth of all, apply this concepts. Actually get to work some decent problems, I guess. Not hard, not hard, but we'll get there. So, what do we have? Well, what I have is I have to set up the pen first. So set up the pen, so I'm ready to roll. Check the other pen, make sure it's in good shape too. Yes, we're good. Alright, so a good way to start almost anything is get the definition out of the way. Get it down solid. What is a subset? A subset is expressed like this. It's almost like a less than or equal sign. It means everything in here is in there, and there might be some extras over here in B. But at least everything in A is also in B. So put it whatever way you can. If you think of something really clever, let me know. I've never come up with something really great about that. And of course, you'll mark across here. We put a line across, that means it's not a subset. But either it is or it isn't, right? And the clever one down here to remember, every set is a subset of itself. Let's take a quick look here since we've got some time. And where's my, good, there we go, okay. So let's take this set. Let's say this is a set that has A, C, and R in it. And A, R, and C. This is the same set. Remember, equal sets, they have the same things. The order doesn't mean a thing. The important thing is for this subset to be true, anything you see in here, you have to be able to find over there. A is here, it's over there. C is here, it's over there. R is here, R is over there. Good. Checks out. Now, that means very simply, because we've just used one example, but you can probably expand this or extend it. Every set is a subset of itself. So if you start with a set over here, and it has some things in it, and you've got the same thing over here, then when you pick something out of this set, of course, if these are the same, you're going to find it over there. Find another piece, it's also going to be there somewhere. So every subset is a subset of itself. So how about this one? I'm going to write either this, or you want to write this in the blank below. If you can find everything in here, if you can find this somewhere in there, then it's going to be a subset. If you can't do that, then this will be the case. So if you take 1, I see it over there. Check. 3, I see it over there. 5, I see it over here. 7, I see it over here. Now, it doesn't matter that there are some extra ones over here. Every one in the first set is in the second set. So, A is a subset of B. That's That's how you go about it. Take the first set, see if everything there is in the possibly bigger set to the right. How about these two? A little bit different. It's sort of interesting. I've never seen this one before, but this is a good example. This is example number 2. We'll set off here a little bit. We've got set A and set B. So here's what you're trying to figure out. Which of those symbols can you put there? Well, maybe you want to use the roster method to get a little bit clearer on this. What does A have? Well, A says the set of all x such that x is a letter in the word proof. So A contains P, contains R, contains O. We don't need to put O twice. Come on, really? And we have F. So it's got 4 different letters. They have to be different, or we're not going to waste our time rewriting them. So what does B look like? Well, B contains, if you look up here, contains an R, contains an O, contains a second O, but we don't care about that for sets, and it contains F. So is everything in here also found in the second set? Well, no, because P is in set A, but it's not in set B. So it's not a subset of set A. And there's our symbol with a line through it. Next, proper subset. Very close. In fact, you might sometimes think subsets are proper subsets, but they aren't. Just subset in general means it might be the same set. Proper subset means it's a subset, but there's some extras in B. Okay? So for example, we've got sets A and B here. So what is A? You've got a person and lives in San Francisco. B is a person and lives in California. So ask yourself the important question. First of all, is A a subset of B? So if someone lives in San Francisco, do they automatically live in California? Yes, unless there's another San Francisco. Second, to be a proper subset, because we can write this, can we write that? That's the next question. Are there some people in California that are not in San Francisco? How about the people in Los Angeles, or the people in San Diego, or the people in Sacramento? Yes, there are some extras. And since it's a subset, but there's some extra ones over here, then what we've got is a proper subset. So both of those apply, because this first part says it's a subset, yes, but it's not only a subset, but a proper subset. So both of those are true. Anything that's a proper subset is, of course, a subset as well. Check this out first, and then check and see if there's some extras in the second one. Extras in the second one mean it's a proper subset as well as a subset. Let's see. Let's see if I can clean this. Here, right? Erase all ink on one side. Okay. Make sure it's still got the 8 going there. All right. So we've got some new sets here. We've got a set A and a set B. And what do we have going? So first, check. Let's go 2 steps here. So first of all, A is a subset of B. So first of all, check. Is everything you see in A also found somewhere down here? Is it 2 also down the bottom? Yes. Is 4 down there? Yes. Is 6 down there? Yes. Is an 8 down there? Yes. Okay? So that's true. Now, second, is A a proper subset of B? Oops, I didn't mean that. Put that there. Are there any extras in B? Well, I see the 2, 8, 4, 6. I don't see any extras. In fact, if you look closely, the cardinality of both are the same, so it can't be any extras. So it's not a proper subset, it's only a subset. Next, the empty set as a subset. No matter what set you have, the empty set is always a subset. Even if you don't tell me what your set C is, I can still tell you that the empty set is a subset of C, no matter what your set C is. Keep that in mind. Usually, it's a proper subset. If there's anything at all in B, it's a proper subset. If there's nothing in B, then it's also the empty set, and it would look like that. Next, number of subsets. Remember I told you this is a little bit of fun. It's not hard at all. So we have a list here. This is a good way of starting. First of all, on this side, we start with the simplest set possible, the empty one. There's nothing in it. That's the number of elements in it. This is the only subset it has. That's a good thing to remember. The empty set's only subset is itself. Number of subsets, 1. There's only one subset here. Next line, we've got a set containing one element, and of course the empty set is a subset, and the set itself is a subset. So it has 2 subsets. So you have 0 elements, you have 1 subset. 1 element, 2 subsets. How about for 2 elements? For 2 elements, you got 2 there, and you got the set itself, the empty set, and the set with just A, and the set with just B. Total, 4. So for 2 elements, it's 4. If we create a small table for ourselves on the right, 0 is for the number of elements, and this is for the number of subsets. 0, 1 subset. 1 element in our set, 2 subsets. 2 elements in our set, 4 subsets. And if you look at the next line, with 3 elements, you have 8 subsets. 3 elements, 8 subsets. Do you see a pattern? In this one, n equals 0. In this one, n equals 1. Oops. N equals 2. Oops, 2 is already there, sorry. N equals 3. Can you see the pattern? Well, the pattern is this. If you have n elements like the 0, 1, 2, and 3. Then the number of subsets is 2 to that n power. So here, this is 2 to the 0, which is a 1. This is 2 to the 1. Notice the 1 over here, the 0 over here. It's 2 to the 2. This 2 comes from right here. And this is 2 to the third power, and that 3 comes from there. So if you had a set that had 5 elements, how many subsets would it have? Very simply, 2 to the n. In this case, 2 to the 5th power. So if it has 5 elements, it's going to have 32 subsets. If you've got a set that has 10 elements in it, how many subsets will you have? It will be 2 to the 10th, or 1024. You can see the number of subsets really goes up fast. Now, last of all, closely related, the number of proper subsets. Now, it's very close, so make sure you keep these two separate but similar. To get the number of proper subsets, the only one you're throwing out is the set itself. So that's 2 to the n minus 1. So if you've got a set, let's suppose you've got a set, let's just call it A. And A, let's suppose, has 8 elements. And we want to know the number of proper subsets. So that'll be 2 to the n minus 1. So it'll be 2 to the 8th, subtract 1. 2 to the 8th is 256 minus 1. So if your set has 8 elements in it, it can have 255 proper subsets from it. Okay, quick one here. So, subsets, proper subsets. Okay, hit the pause button, see if you can figure this out. Come back and I'll show you what to do. All right, have you given it your best shot? Come on, give it your best shot. First of all, the number of items you've got is 5, so the number of subsets is going to be 2 to the 5th. 32, we had that as part of our example earlier. Number of proper subsets, all we have to do is subtract 1. So 2 to the 5th, subtract 1. Subtract 1 from the total, not from the 5. 31 proper subsets. I'm going to make it a little bit short there. How about this one? First of all, how many items do you have? Well, it says you're talking about natural numbers, that's counting numbers, from 9 to 15 inclusive, because it includes 9 and it includes 15. How many does that give you? Got it? You have 7 elements in that set, 9, 10, 11, 12, 13, 14, 15. Now how many subsets do you have? 2 to the n subsets, 2 to the 7th, 128 subsets. Now, how about the proper subsets? Proper subsets are just one less, because the only one we're not including from this is the set itself. So we'll have 2 to the 7th, subtract 1, or 128 minus 1, or 127 subsets from that set. Now we get to something a little bit on the exotic side. This is a little bit unusual. It looks almost like an N, but it's not an N. If my memory serves me correct, it's actually a Hebrew letter. And it's the Hebrew letter Aleph. And with that 0 down here, it's called Aleph Null. Null as in none for 0. This is how many natural numbers there are. So look at how many subsets it has. It's 2 to that number. How many proper subsets? Just subtract 1 from the total. Now, it talks about transfinite cardinal number and so on. We're not going to bother with that, but if you're interested, this is the smallest transfinite cardinal number. That's really getting exotic. If you want to find out what transfinite is, or transfinite cardinal numbers, go ahead and check out the internet. Get a good video so you can find some more. I'm not going to push this one because you really don't need to know something like that. All right, so you should be ready to go. So here you go, your assignment, and this is for section 2.2. Try that again. Oh, so if I hit that, everything goes away. I just learned something. So, section 2.2. And remember, this page number, this should be the 24. I'm going to be a little bit liberal this time because I've had some trouble creating these videos. We'll see how things go. Remember, this is for version 7, so it might be slightly different for version 6 or edition 6, but hang in there. It should be real close. Well, that's all for now. We're going to close up shop for the day, and you get started on those.